Hey, wake up! Hey, wake up!
Huh? Huh? This is lesson 9.2, and the topics for this lesson are: download satellite images of Sentinel-2 from Copernicus websites, install a plugin, semi-automatic classification plugin, SCP, download satellite images of Sentinel-2 from QGIS, processing satellite images of Sentinel-2. Reflectance, atmospheric, create band sets and band combinations. Spectral signatures, how to manage spectral signatures in QGIS, how to monitor a superficial contamination remotely. And the website we are going to visit is Copernicus Open Access Hub.
Hello guys, this is lesson 9.2 and today we are going to be working with satellite pictures from Sentinel-2. First of all, let's go to see the link number 6. Copy. This is the main website for Sentinel-2 to download the satellite pictures. If you want to download the pictures, you have to register, you have to create an account. Now we are going to go to Edmonton. Select the area you want with the polygon. You're going to mark all this area. Click right to finish, double click to finish the polygon. Now we have the area we are interested, then click here. I'm going to select we are going to leave this one, ingestion date, and the sending is okay. Then for ingestion date, I'm going to put a range of days, for example for the 1st May 2018 to 19. But if you want a specific day, you have to put the same date here and here. Then you have to select the mission. In this case is a mission Sentinel-2. And also you can select the cloud cover. You can put a range here. But I'm not going to recommend this option because sometimes if you are working in an area and you select this kind of option to avoid satellite pictures with a lot of clouds, maybe the area you are interested there is no clouds, right? And maybe you can use that image, but if you make this restriction, you are not going to get that picture, okay? It's better to check picture by picture and select what do you want. Okay, now search. Okay, now we have all these pictures as you can see here. 25 pages, that's a lot. Then for example this is Sentinel-2, as you can see here, Sentinel-2 28, okay, and this is the date 2018 05/15th, okay. Then you can click here to preview. It is taking a lot of time to load the information. If it happens, I'm going to pass the video faster, okay. Now you have here the information for the product. As you can see, it used to be heavy files. That one is not too heavy because it used to be around 1 GB. That's because this picture just has also just this area, okay. Sometimes the image is bigger. Let's go to see another different. This one, for example, this is 28/5/15. Is the same one, but there are more coverage for this one. As you can see, this one is almost 1 GB. Then The process is just click here, download. Okay, and then you have to wait. That one says it's going to take 8 hours, but it used to take around 1 hour and a half, something like that. It depends on your connection, okay, to internet. Okay, I'm going to cancel the process because I have already one file downloaded. And that's it. That's the way this website works, okay. But now we are going to see how to do all this process through the Quantum GIS, okay. Close. Let's go to Open Quantum GIS. First of all, we have to install a plugin. Then go to plugin. Remember, you have to be connected on internet to download the plugins, okay. That one, the name is semi-automatic classification plugin is this one. This plugin is really popular and it works really well. Then install plugin. Okay, make sure you have click this box here. Close, and we have the plugin already here. It's that one, SCP, semi-automatic classification plugin, and you have here all the tools, okay. Then to download image is this option. Then you have to select Sentinel 2, but you have also different options, okay. As you can see here, you have Landsat, Aster, and Modis, but we are going to work with Sentinel 2. But for the other cases, are more or less the same, okay. As I said, if you want to use, if you want to download the image directly with Quantum GIS, you have to be registered in that page, okay, and that one I showed you before. Then you have to put your user and your password. And you are ready to download the images, okay. Let's go to load the web here, Google Street Maps, because we are going to mark the area we want to search the information, okay. That one is going to be in Edmonton also. Okay, it's going to be this area. Okay, the software crashed, and now I'm going to try again. Just go here, open Street Maps. This is the plugin SCP. Go to download image Sentinel 2. Okay, let's go to search Edmonton. Okay, that's good enough. Now the options we have here, if you want to download images, you have to register in the website I showed you at the beginning of the video. Then you have to put your user and your password. Just to let you know, when I did that one, the first day it doesn't work on Quantum GIS, but the second day works perfectly, okay. To select the area where you want the satellite image, click this button here. Go to the map, select the area you want, click left for the first corner. To the corner opposite, click right, and you're going to have the area. This coordinates here, this one is for the top at the left, and this one is for the bottom corner at the right. Now you have to select the days. If you want just one picture, you have to put the same day in both boxes. But if you want a range of days, you have to put the beginning date and the last date. For me, it's going to be from April 1st to May 19th. The cloud cover is going to be 10%, but as I said before, it's better if you don't put anything here, keep 100%, then you can check the pictures. Okay, let's go to find the satellite pictures. Just click here, and if the process is very long, I'm going to pass the video faster. Okay, the process is already complete. Now here we can see the cloud cover. Here is the coordinates. Here is the size of the file. Okay, let's go to see some images. For example, from here to here, just click this button. Okay, I'm just interested at the Edmonton area, then I'm going to remove all these pictures. Okay, for me the best one is this one. There is not too much snow, and this one is from 2018 May 12th. Then I'm going to remove all these ones from here to here. Remove. Okay, then we have to look this one here. Zero 01 5082. This one. Then we have different options to download the image. Pressing here, you can select the bands you want to download. I'm going to leave all the bands. Also here, I'm going to do the process. I'm going to do the process after I downloaded all the images, and also I don't want to load. Then click here to download the image. If you leave this box click, it means you're going to download this one. Select a file, and when the process is finished, it's going to make a noise like beep. Okay, then I'm going to stop the video here because this process is going to take around 1 hour and a half. Okay, the file is already downloaded. I don't know how much time it took to download the document, because I leave the computer working at night, but I'm pretty sure it took more than 2 hours. Okay, the file is in lesson 9. Is this file. Okay, as you can see in this file, you can see the date here. This is 2018. This is the month. 05, it corresponds to May, and this is the day 12. Okay, now we are going to keep doing the process. Okay, I'm going to add one of these bands, for example band number 2. Okay, as you can see, the range for the values here, that's a digital number. We have to convert this digital number in reflectance, because we need the reflectance to create the signal spectral signatures. Okay, and also we have to do some atmospheric correction. Okay, to do this stuff we're going to use the same plugin. Okay, let's go here as we did yesterday, download. We have already the file downloaded. Then we have to go to here to processing. Okay, then select the directory. You have the folder with the bands. Is this one here, select, but I have the option for Landsat. You have to select Sentinel 2. Okay, now you have all the bands here. Okay, we are going to apply for atmospheric correction. Okay, but we are not going to create a band set. We are going to do later. Okay, then I'm going to unclick that one. This process is going to take around, it depends how heavy is the file, right? But it used to be around 30 minutes to 1 hour. Okay, I'm going to click to run the process, and I'm going to pass the video faster. Well, first we have to select where we want the new files with the reflectance. Okay, folder, going to put reflectance. Okay, I want the information in this folder. Select, and now the process start. You have here the bar process, and I'm going to wait until they're finished. Then I'm going to explain more things. Okay, the process is already finished. Let's go to close this one. This is the new folder with the files with reflectance. I'm going to load one of these ones. Well, we have all these ones loaded already, as you can see here. RT, it means reflectance. We are going to remove from here to here, remove all these ones. Okay, as you can see now, this is the information for reflectance. Okay, at the band 12. Now we are going to create the band set. To create the band set, you have to click this button here. Oh, sorry, you have to have all these bands here. Yeah, I'm going to add the bands again. Desk, and number 9, reflectance, from here to here, all these ones open. Okay. Now go to band set, refresh. Now we have all the bands. We are not going to work with all the bands. We are going to choose this one. We are not going to select I believe it's better to select all the bands. Then I'm going to take out the band number 1, band number 9 and 10, and I'm going to load all the other bands. Okay, just click here. Now you have all the bands here. you have to be aware these bands has to be in order. To order the bands, just click here. Okay, now you have 2, 3, 4, 5, 6, 7, 8. After 8 has to be 8A. Okay, then click on this band and go up. Now that's okay. Click again. Now you have to go here, quick wavelength settings, then you have to select Sentinel 2, and now you have all the centers wavelength. Okay, but as you can see here, we don't have band 1 and 9 and 10. That's the reason, because I'm not going to use these bands. Okay, and now you have the option to create a virtual raster, and also all these options, but we are not going to choose anyone. Okay, because we are going to create something to do a training input. Okay, then click here, select a folder. It's going to be this one. Select. Now you can close. Now we are going to create a virtual file here in input, training input. Click here, select a folder, lesson 9. Here, I'm going to put training, save, and that one is going to create a temporal file, as you can see here. Then let's go to make some compositions. This we have to wait a little bit until the file is created. Okay, we have there the band set as a virtual layer, as you can see there, virtual. This composition is 3, 2, 1. But first, I would like to mention one thing. As when we did the band sets, okay, as you see here, we don't have band 1. Okay, then the software assume this one, as you can see here, the numbers. This is 10, this is 9, 8, and etc, right? For the software, this band now is number 1. Okay, that's really important. No, not to mix the things, right? Because it's a little bit confused. This one now is going to be band 1. Even here, say band 2. For the software, it's going to be band 1, and this one, number 2, it's band 3. Okay. Then I created this Excel to show these things. Okay, this is the bands for Sentinel, and this is going to be the bands for the software, for the plugin we are using now. Okay, now when we put this combination 3, 2, 1, okay, 3, 2, 1, the real one is 4, 3, 2. Okay, but to work with the software, we are going to put 3, 2, 1. Okay, that composition is for real color, but the real one is 4, 3, 2. Okay, 4, 3, 2. But if you put here 4, 3, 2, it's going to be the composition 5, 4, 3. Okay, yeah, a little bit confusing. And let's go to take out all the bands here and keep just this one to work fast. Then this one, it's a real color, but it doesn't look like, right? Then we can make some modifications here in properties. The easy one is just go here, and that one for me is the best. You have to load, click here, and then apply, and it looks a little bit better. Okay, now we're going to create spectral signatures. That's a very important thing. To do that one, just go here, classification doc. Okay, going to make this bigger. Okay, Now we have macro class, MC, and class. For the macro class, we are going to put water, and for the class, we are going to put river. And now let's go to pick up some samples. Okay, you can take an array. Okay, this is region of interest. We can take a polygon, or we can take a pixels. Okay, this is the difference could be between two different pixels. Okay, for example, we would select that one. As you can see, every pixel has different number. Okay, this one it's the minimum pixels, and this one is the maximum one. Okay, for example, if I click here, as I put here 100, this is 100 pixels. Okay, but if I put here 50, when I click, it's going to pick up just 50 pixels. Okay, but if I want just one pixel, I have to put here one and click on one pixel. Okay, now we have one pixel. It's that pixel over there. Remember, the pixel is 10 by 10. Okay, and now when you press here, let's go to put number 1 here. When you press here, you are going to keep this spectral signature. Okay, let's go to click here. You have this one here, and if you want to see the spectral signature, just click here and click this button here. Okay, now we have the spectral signature. Then we have here the wavelength. Okay, here, and here we have the values for the reflectance. 0 there. Okay, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different values for the reflectance. Every of these lines, it represents the bands we have. Okay, I would like to show you one thing. Okay, is this one, this line. Okay, it is this band number 2, this one is number 3, and that's because the spectral resolution is really important for the satellites, because as much bands you have to be more accurate with this curve, and you are going to have more values to make a spectral signature. Okay, okay, now we are going to pick up one more pixel. I'm going to minimize this one, go here, I'm going to pick up this pixel over here. Okay, I'm going to call this one, I'm going to leave the macro class as a water. For the class, I'm going to put river 2. Keep, and now I'm going to select both of these ones with shift. Now we're ready to see the spectral signature. Is this one here. As you can see, this one is quite different than the number 1. Okay, that difference has to mean something. Okay, I don't know, but it means something, because maybe because we are very close to the soil. I don't know, maybe the water is less deep. Okay, let's go to pick up one more sample. For example, this one here, river 3. Save, and now let's go to see the spectral signature for this one. As you can see, the number 3 is the same as the number 1. Okay, let's go to pick out one more. For example, over here, this one, number 4. Save. Let's go to see it. Going to take these ones out. Now you can see number 4 is the same as the other ones. Okay, but number 2, it's a little bit different. Okay, one more. But now we are going to pick up one on this area here to see the difference. This is a bank of sand. Okay, we can click here, and that one has to be different, okay, because it's not just water. Okay, number 5. Save. I'm going to change the color of this one because it's very similar to this one. Now let's go to see the spectral signature. For number 5, as you see, oh sorry, this one is a little bit different. You see that one goes here. If you compare with the other ones, no number 2, because that, I don't know what's going on with that one. Okay, but that one, the reason is because we are on the bank of sand. Okay, we select this one, for example, number 6. Number 6 is this one, and it's also different, right? Because now we are working on sand, as you can see here, and that's a very interesting one because, as you can see, every pixel has their particular information. Okay, now for example, if you have a contamination here, the river, okay, with hydrocarbons, for example, if the hydrocarbons are less dense than the water, that hydrocarbons are going to float on the water. Okay, and the reflectance for that pixels, the ones we have hydrocarbons, are going to be different. Okay, you are going to have a different spectral signature. Okay, and that one is going to be reflective here. Okay, then you can monitor these kind of things. For example, when you have a river, okay, you can check for example before the contamination and after the contamination if there is something different, right? Of you are doing field work and you know this area is contaminated, you can compare one pixel from here and one pixel from here. Okay, because you know, now we are going to take a sample, for example, from other different part of the river, but at the same river. For example, from here, I'm going to take one sample here. That one is going to be number 7. And has to be the same as the other ones. Okay, that's when it's in pink color. Select all these ones. Great. Okay, the last one is this one. As you can see, it's pretty close. Okay, then what I said. Okay, if you have a contamination, something is going to happen with the reflectance. Okay, it's going to act in a different way. Okay, because maybe the hydrocarbon is going to absorb more the, I don't know, for example, the band 2, or is going to reflect the near infrared better. You know, you have to do your own investigation, okay, because every material has their particular characteristics, okay, and you have to do the field work for that one. But after you know what is going to be the spectral signature for this X scenario, you can apply that one for other rivers and other parts, you know. That's awesome. You can use also that one for a contamination in a land, for example. You know, there is for example, if there is a superficial spill, okay, and you can check the reflectance for the pixels, okay, and you can compare contamination without contamination, okay, and you can monitor that one, you know, every month how is the evolution of that contamination. You know what was the reflectance when the soil was not contaminated, and now you know what is the reflectance with a contaminated soil, okay. Then you can monitor remotely. You don't have to go to the field. You know, there are satellites with a really good temporal resolution, you know, for every day, even if you want to pay for that one. But in this case, for example, you are going to have a temporal resolution for 5 days, okay, or even short. And also you can take a sample of a polygon if you want to have a specific area. For example, I want all these ones. Then you are going to do the same, number 8. And now you have a spectral signature with the mean of all these values. This is this one. Let's go to see how it looks like. Is the last one. This one. As you can see, it's more or less the same as the other ones. Okay. You can do the same for the land here. I'm going to show you with Google Earth. Okay, is this area and this river, and we have this area. We can do a different one. Now, for example, we are going to take some samples here, okay. Then the macro class is going to be, for example, land, and it's going to be number 2. It's a different one, okay, and the class is going to be number 1, and we can put vegetation 1 and pick up one sample. This one, for example, sorry, has to be the pixel because I want to take just pixel by pixel. Okay, now you can see the spectral. As you can see now, this spectral signature is totally different. Is this one here the land? I need to take these ones out because I don't want to see it. Now we are working with the land. Is this spectral signature? Okay, let's go to pick up a few more samples. For example, I'm going to take these ones out. That one changes automatically. Okay, you don't have to do that anything. I'm going to pick out one sample, for example, here. This is number 9. Save. As you can see, macro class number 2, class number 1 and number 2. Okay, let's go to see spectral signature. Okay, as you can see, they are very close. Okay, no big difference. Okay, one more to pick out one more over here. That one is going to be number 3. Save. Let's see what happened. Okay, right there, almost the same. As you can see here at the legend. But now we are going to go outside to this area. Okay, let's see what happens if we pick up one sample here. Number 4. Save. From here to here. Show me the spectral signature. Okay, as you can see, now we have something different. Okay, different kind of soil or different kind of vegetation, different spectral signature. Okay, as you can see, that one, it's a different one. Now let's go to pick up one from here. This is number 5. Save. Let's see what's going on. You see here, this one. That's a different one. Okay. The reflectance in this case is very close to this one, pretty similar, but it's less reflectance. There are more absorption in this area. Okay, let's go to pick up one inside the field, one inside here, in this area here inside. This one here, for example, and that one is going to be class 3, number 1. This one is going to be industrial or oil and gas, for example. Oil and gas, and it's going to be sample 1. Okay, now let's see from here to here. We have this one here. As you can see, that's different. Okay, has different behavior. Let's go to pick up one more. For example, let's go to pick up this pixel here. This one here. It's going to be number 2. Spectral signature for the last one is this one. I'm going to take some of these ones. Okay, that's the difference. Okay, as you can see, for oil and gas, both of them are pretty similar, but for vegetation, we have a different spectral signature. Okay. Also for the water, totally different. Okay, for vegetation, different. Okay, now I'm going to stop this video because it's already 45 minutes, and I'm going to create lesson 9.3 with more about spectral signature and how we can classify the surface with the spectral signatures. Okay, but that one is going to be the next lesson. See you then.